ExactFlat. I'll let them introduce themselves.
Good afternoon, everybody. This is Ethan Donald, CEO of ExactFlat.
Thank you. Ethan will be presenting the design phase of this process, and the goal today really is to set a brief introduction to streamlining the process flow from interpreting your customer's requirements through the design phase and then transitioning to the cutting system. During the presentation, you have the ability to ask questions. There is a questions pane on the right-hand side of your screen. You can simply type in your question, click send, and then at the end of the presentation, we'll have a little question and answer session and answer as many as we're able to. I think that's it. We'll let Ethan get going.
Thank you, Liz. Welcome, everybody. My name is Ethan Donald. As I mentioned before, I'm the CEO of ExactFlat. ExactFlat is a software add-in for SolidWorks, which allows you to design and manufacture pool liners with increased productivity, reduced time, and reduced effort. We're going to be talking about 7 things today. Really, ExactFlat, the combination of ExactFlat and SolidWorks is useful for the design, first of all, of the pool liners, pool covers, spa covers, that type of thing. What we're going to be covering today is a workflow giving you an example for an in-ground swimming pool. There's going to be 7 things which we'll discuss: opening a template, dimensioning the pool, creating panels, flattening it, patterning and nesting, and exporting the cutter. There's one aspect specifically I'd like you to keep in mind as we get into this, and I will not talk too much about this, but we're going to show you the design process. The design process we'll show you typically has post-design elements, so things that you would normally do after your design is finished, like, for example, putting alignment notches on and things like that, which some of our customers have historically done manually by laying their pool panels on the floor and using physical media like a Sharpie pen to line these things up. We'll get into that a little bit, but I just want to call that out. There's going to be 2 aspects: the design process and a post-design process. We're going to show you how you can combine both of those. So without any further delay, what I'd like to do is I'd like to bring up a model of a pool here. There we go. So this is a pool that has been modeled in SolidWorks. This is a Grecian with mitered corners. You can see it's a fairly standard design. You can have any kind of design you want. For example, if you wanted to have a different hopper shape, or if you wanted to have a 2-slope, a pool with 2 slopes down from the shallow end to the deep end. If you wanted to model in the safety ledge, all of those things can be done, and they can be done very easily. I will say that what we're working here with is a template. So there's a process for creating a template, and then there's a process for adapting it. If you're creating a template, models like this, they would be, depending on your skills with SolidWorks, you could model them in anywhere from 5 to 15, maybe 30 minutes on the absolute maximum side of things. But generally speaking, a very competent SolidWorks designer would create a model like this in about 5 minutes. But once the model is created, you don't have to really know the modeling process. You can just dimension your pool. And so you can see we've got a little form here. And while this pool itself is a 20-foot by 40-foot pool, we're going to go ahead and change the dimensions here by just literally typing in values. So we could change this to 434, which would be a 36-foot. We'll change this one here, this 240 to say 216, which will be a 18-foot, and we'll change the depth of the hopper from, say, 8 feet, which is 96 inches, to, say, for example, 84 inches, which would be 7 feet. And you can see the dimensions are changing as we make that update. So that's pretty simple. We're not going to accept these changes. We're just going to go ahead and cancel out of here. And we're going to go back to our 20 to 40 foot, so you can see how quickly it is to change from one to the other. And, for example, if you wanted to make that data entry part of what your customer interaction process is, you do have customers who are looking at automating that by putting a web form up, and the web form would post to an Excel spreadsheet, and the Excel spreadsheet would come in, and all that front-end process, which is repeated over the number of pool liners that you create in a season, would be automated. So here we have the pool. We are now going to start the process of just creating the patterns, and we'll just focus on the pool bottom. We won't bother with the walls for now. So what we're going to do is we're going to select the panel pieces here, and we just click on the panel piece and click Create Piece, and you can see it's that easy. And we can design the panel pieces in any way that we think is appropriate. So we could have these panel pieces run straight across from sort of like left side to right side as we're doing right now, or we could create them in other ways that make sense depending on how we want to weld the pieces together afterwards. If you have really complex geometry and you want to simplify the manufacturing process, this is where you could actually design in such a way that while your design process is not necessarily faster, the downstream manufacturing processes will be much, much faster. So it's a flexibility that's built into the system. And you can see from a complexity standpoint, it's just a matter of selecting the pieces, and there you go. You create what you want. So let's go ahead now and just accept that, and then we're going to convert this to an ExactFlat part. Now what that means is we're going to have these horizontal lines here, which are slice lines of where we want these pieces. We're going to assign a material, and we can assign two types of material here. You see we just got PVC bottom and PVC top. So for example, if you've got a particular pattern design on the bottom, which is different from the pattern design on the top with sort of trim coping tile or something like that in the top, you could do either one of those. If you had a 5 millimeter, a 5 mil, or say a 7.5 mil, or say a 3.5 mil thickness, you could assign any type of material to whatever aspect you wanted to assign here. So let's just go ahead and pick the PVC for the bottom here. We'll go into our flattener view right now, and this is where now the pieces are going to get unwrapped and flattened. And you can see for the pieces that are already flat, there's no need to go through a flattening process, so they don't need to be brought in here, but we'll just go through this. This will just take a minute or two as we flatten these things out and then hit the optimize button. And what's happening right now is we're optimizing the size and the perimeter of the panel pieces so that all the stretch and the sag is removed. So no wrinkles, no excessive stretch. It's designed to stretch a little bit, but not too much, and designed to have the wrinkles removed. And that process, you see, takes about 10 seconds. 10 seconds or so, excuse me. So let's click OK here. Now we're going to go into our pattern view. And you can see here's our pieces. We're going to update the pattern with the results from our flattener. And now we're going to go ahead and just lay the individual pieces out in a way which is analogous to the way that they're going to be welded together. So let's just go ahead and grab the hopper there. We'll just put the hopper in the center. And it's very simple to lay it out. You would just click on the edge, and then it'll find automatically the neighboring edge. No need to hunt around for how your pieces are. And this is particularly useful in custom pools that are non-standard. You can do this very quickly. And if you can visualize when these get put together, they would take the shape of the bottom of the pool. And there you go. That's it. So the next step is to put some seam allowance or seam offset in so that when these pieces are welded, there's an overlap for welding. We're not going to go through doing all these, but you can see what we do is we just select an edge, what we call the primary edge, and then the secondary edge is automatically found, associated, and selected. We're going to put a seam on here now, say for example a half an inch overlap. And you can see how it's updated there. Next thing we'll do is we're going to create some alignment notches. So we'll just create, say, an array of 6 notches here. Now, for those of you who are working in post-design or post-CAD design by laying your pieces on the floor and then manually kind of walking the patterns and associating them with one another using, say, for example, a Sharpie pen or so on, this eliminates that process. You can actually substantially increase the productivity on your post-CAD design processes just by going through the step here. You can see the little V notches there. That would be printed out on the Eastman cutter, and you're ready to go from the table to the welding station without any intermediary steps. So let's go ahead and put another set of seam lines on here. Let's just pick the other piece here. So you see, click the edge. There you go. And then you select the join type. In this case, it's a half inch overlap, and you can, depending on the type of joins you want to have, you can put any number of join types it supports. Say, well, I'll put 6 alignment notches on that edge, and there it is. That's how difficult it is to put these alignment notches in place. Okay.
Eaton, this could be a good time to take, can you get right back into it, or is it a good time to answer a question?
Yeah. No, we can answer a question now, sure.
So there's a question here. When you're talking about the design library, it can take, you're suggesting 10 to 30 minutes to create a model, but this customer is saying they can typically create a Grecian type pool within like 3 to 5 minutes. So this doesn't seem a lot faster. So can you please elaborate on how this is going to save them time?
Well, there's two aspects. One is creating a template, and the second is using that template. So once your template is created, which can be anywhere, say from 5 to say 30 minutes, depending on how complex your model is. And for a model like this, it's about 5 minutes. The second piece is when you use that template, when you just open up that template and use it, it is 30 seconds to dimension it. So the dimensioning process that we showed at the beginning, where you've got a form, you literally punch in values for, say, the width, the depth, the safety legs, the slope type, and all that kind of stuff. That's what you would typically do once your templates are created. Depending on how many pools you do offer, how many different pool designs you offer, you would have any number of templates to support that. And you may have some that are sort of ready for customization and some that are more standard. So I don't want to make it seem like you have to draw from scratch each time. You can actually have a number of different designs that are saved as templates, and you go from there. And in fact, because of the power of SolidWorks, you can create macros which further add efficiency to your process. So here we have a slightly different shape that we've just nested, and we're going to stop the nest right here because there's no need to really let it run any longer. We're going to accept that. We're going to hit the export button. And now you can see these are some of the layers that are supported in terms of notches or zones if you've got pieces with a different quality levels, but that doesn't really apply for PVC vinyl. So we're just going to export that. We've got a preset for the Eastman cutter. Save that. And we will just go and open this file up again. Let's go to our file folder here. And there's our nest file, which is analogous to the file there. So this is ready for the cutter. Now I just have to emphasize at this point, you're ready to take this to the cutter, and once it's cut, it'll be notched with alignment of notches that will make it ready for the welding station. So you don't have to go through a separate process in order to do that. So there's two things, efficiency in design, and then post-design, you've got your materials prepared in such a way that you can get to the subsequent manufacturing step, cutting, and then in this particular case, welding very, very quickly. So that's it. That's the process. And generally speaking, if you're doing it from scratch like this, you can expect about anywhere from say 7, 8, 9, maybe 10 minutes or so that you can get through a project, with substantial opportunities for further design automation depending on how you run your business. So why don't I stop there? If there's Matt, I'll hand it back to you, and maybe we can talk a little bit about what happens on the cutting process and some of the efficiencies that come from the Eastman equipment that can complement ExactFlat.
Sure, sounds good. Okay, Mike, take it away.
All right, thank you, Matt. Hello, everyone, for this afternoon session. Basically, now you're into the cutting stage after making your actual file for the cutter. There's a couple things you're going to take care of after that, right before you actually start cutting. And one of the things you have to consider is material handling. You're going to have your rolls of material, whether you're going to store them or have them right at the cutter on the back of a power feed system. Now, in the picture you see right now, you see one of our power feed systems. What this system does is this helps reduce the amount of tension coming off the roll. If anybody's worked with vinyl before, you know that the vinyl sticks to itself, so if you pull it onto a vacuum table, it actually stretches. So what this system does is it helps power feed it to the conveyorized system, which is one of our cutting systems, to help eliminate the stretching of the actual material. If you could go to the next frame, please, Matt. Now here you'll see actually 3 different type power feeds. But the first one's actually a roll stand. This is actually going to hold your vinyl, and what's unique about this system is it'll help align your vinyl. Although the vinyl is woven pretty straight, you still might have a little bit of a variation in the roll, what we would all call telescoping. So the edge alignment on this will actually keep that roll straight as it's coming out of the conveyor, so you don't form wrinkles. The next system, which is the middle one, that's an actual power feed system, which with the power assist. That's what the rollers are in the front. That helps the vinyl reduce the stretch. You'll also see that you have 3 rolls in the back. That'll allow you to store up to 3 rolls on it at one time. The last system over to the right, that's a power feed system as well, and that also has edge alignment. But you'll notice the difference with this one is it has a removable cart in the back, which will hold 6 rolls. And what this will allow you to do is interchange the rolls while you're actually running the machine. And then when that cart gets exhausted of the vinyl, you can actually wheel another cart in its place and then load that one cart again. Next frame, please. Another thing you have to consider when you're cutting the vinyl is how you're going to mark it. Most of the places I've seen mark the vinyl with a pen. That's a standard on all cutting equipment. There are other options for marking, but with vinyl, primarily it's going to be a pen. Now, if you get into safety covers, you might be considering an airbrush. It's a non-contact marking system that basically is going to spray a washable ink, which comes in different colors, white, yellow, and you basically spray either your part number or your lines for where your Velcro straps are going to go or whatnot on the actual cover. The other 2 marking systems that you see, the adhesive labels or the inkjet, the adhesive labels is exactly what it sounds like. It's an adhesive label, and it prints on it and then pushes it down onto the material or the pattern that you're actually cutting out. The inkjet system is an actual system that is similar to the airbrush. However, it actually does a crisper type label for the marking, and it'll go in multiple directions as it's marking. Typically, this is something that's used in the aero industry. Next, Matt. Thank you. These are 3 of our cutting systems that we currently have here at Eastman. One's a static table. Static tables can come in multiple sizes, anywhere from 8 feet by 72 inches. It can go all the way up to 100 feet by 16 feet wide. These typically are for one-offs or R&D, or if you do have the footprint in your facility, you can get a larger system, which will cut larger panels at once instead of a conveyorized system. That being said, the middle machine is our conveyorized system that will allow you to have a smaller footprint on in your shop floor, but it will allow you to do high production runs. You'll get a higher volume off this machine, and it will also allow you to cut the larger panels out of a roll, so you can actually exhaust the whole roll without having to load and unload the material. The last machine over to the right, the multiply, now typically you wouldn't see this in a industry like with pull liners, unless you had like a secondary type division of your facility where you're doing something else like outdoor furniture or umbrellas or something like that, something to complement poolside type atmospheres. This will allow you to stack up the material high ply up to 3 inches compressed and allow you to cut it at once with a M2 steel blade. So that being said, if anybody has any questions, if you can ask them on the board and they'll let us know. And we also, just before we get into questions, we do have videos. If you're interested in seeing a video at any time, you can contact Elizabeth Magruder that you can see on the left there, or email her, and we can actually send you a video of the equipment in action.
Great, thanks, Mike. So we've got a few questions here. A lot are related to ease of use and training and so on. So, Eden, one of the questions is, how long would it take to go from being a non-SolidWorks user to be able to complete the tasks we're seeing on the screen right now?
Well, you've got a lot of different training options. First of all, SolidWorks resellers are positioned to help you with SolidWorks and ExactFlat. If you're talking specifically about a SolidWorks user that needs training on ExactFlat, we have two programs. One is 8 hours, which is a day, and the other one is 16 hours, which is 2 days. There's also options for larger enterprise installations where you're going to have an administrator for the software. Administrator training is about 8 hours as well.
Okay. Somewhat related to that, typically think of SolidWorks as a 3D modeling tool. We currently work in 2D and don't have any team members currently trained on it. So how relevant, how quickly can we get up and running using the software?
Well, how quickly you get up and running is a different question from where you want to start your modeling process. SolidWorks does support both 3D modeling and 2D modeling. So for example, you could make your templates in 2D, you could dimension them in 2D. It becomes a little bit more tricky when you talk about custom shapes or more complex geometry, like for example a double slope with a safety ledge, for example, in the deep end, right? Not to say that it cannot be done, but it's just very much easier to visualize those things in 3D. And again, once your templates are created, your 3D modeling work is not as intensive as the ExactFlat process, which is pretty straightforward. So depending on where you are in your business, you may start in 2D alone, or you may start in 3D. The choice is yours. The benefit is, if you start in 2D, you've got a very simple, straightforward migration path to a 3D workflow, which generally speaking will be better productivity for you. One of the aspects that we did not go into today, but there's an integrated drawings package and costings package as well. Same thing, it's sort of drag and drop functionality. If anybody wants to know more about that, we can show you how that works, but that is in addition to the 3D or 2D modeling.
Okay, I think that's a good place to wrap it up. Liz, do you want any closing thoughts from your team?
We just want to take a moment to thank everyone for joining us today. And both the Eastman team and ExactFlat team are certainly available to answer questions after the meeting today. The contact information is up on the screen right now, and we will also send out some follow-up information if you think of something afterward. But thank you again for your time.
Thank you.
Yeah, just to echo Liz's comments, thank you for your time. If you need any further information, please do not hesitate to contact us on the screen. Otherwise, you may also contact your local SolidWorks reseller.